Holy hot sauce, it's June 1st. How about it? Today on our kitchen table chemistry, we are going to draw resonance structures, what are called resonance structures. And this will be not like isomerism, but it will look a little bit the same. So first of all, into it. What is resonance? What does it mean? Oftentimes people have a hard time putting an idea on the word. What does it actually mean? You're thinking about an echo and now perhaps with music, but this is the idea. A resonance structure has delocalized electrons. In other words, it's got a double bond. And the resonance structure will have two or more possible electron structures. So in other words, we might be able to write that double bond at two different places and still be successful, still have an octet for everybody. So that's what resonance is. It is not isomerism. It only involves double bonds. Let's see what this looks like. Now, SO2. First thing I want to do is figure out my number of valence electrons. 6 plus 6 plus 6. I have 18 valence electrons to work from. Who goes in the middle of this structure? I'm thinking sulfur. It has the lower electronegativity, so I'll put sulfur in there. And to draw the structure out, I'm going to end up with an oxygen here and an oxygen here. And I'm going to double bond that oxygen because if I do that, now I have all 18 electrons shown and everybody has an octet. If I don't do the double bond, then not everybody has an octet. So I can draw it like this, or I can draw it like this. That double bond can be at either location. Because the double bond can be at either location, this is called resonance. And resonance is only the ability of a double bond to be able to be at multiple locations. So which of these is correct? Both of them are correct. And the average, any substance, any amount you ever had of this would contain an average amount of either one, and I don't know what that average would be. So there we are. Now, this is what it would look like. Sulfur in the middle, double bonded to the single oxygen on one side, and then single bonded to the oxygen on the other side. Okay. Now, I think I was just going to do that. Let's go back here and let's just do this. This is in your homework. CO3 minus 2. So it's a carbonate ion. Carbon's going to go in the middle. It has 4 electrons. Plus we have 3 oxygens. So 3 times 6 is 18. Minus 2 charge means 2 more. So it's going to be 24 electrons. If we put carbon in here, we bond it to all 3 oxygens. We notice immediately that if we don't give carbon a 4th bond, carbon always bonds 4 times. If we don't give it a 4th bond, it's not going to satisfy the octet. So I'm going to go like that, put a double bond there. Now I need to have 24 electrons. Right now I have 2, 4, 6, 8, 10, 12, and this oxygen has an octet now. 14, 16, 18, 19, 20, 21, 22, 23, 24. Now everybody has an octet, and we have this double bond up here. Because this is a polyatomic ion, I'd like you to get in the habit of putting parentheses around with a minus 2 charge. That means that we've added 2 electrons to the structure. So this is one resonance structure. This is a second. I'm going to put the double bond now in the middle. And you're saying, Mr. Winstanley, is that different? I'm saying that is a resonance structure. It is not an isomer. It is a resonance structure. And the double bond could be here on the right. It could be in the center. And if you're saying, could it be on the left? Then you are correct. It could be on the left as well. So these are 3 possible resonance structures for the carbonate ion. -2, like that. Okay, resonance, the ability of a double bond to occur at multiple locations. All right, that was my SO2 slide. Now, isomers, not resonance. So don't confuse the two. And that I think sleepy kids often confuse the two. Isomers are the same formula, but a different structure. And I just thought I would roll through some issues. So this was what you were working on for me on the weekend, C4H9Br. And most of us initially did this, 1, 2, 3, 4 carbons, and then you put the bromine on the end, and that's great. Now, all the hydrogens are there. It fills everything in. I'm not going to draw the hydrogens. This is just to save time. So the other thing you could have done was this, 1, 2, 3, 4, and put the bromine on the second carbon. That would be different. That would be an isomer. So now we are showing two isomers. So the third isomer actually required a bit of thought, and a lot of you came up with it, 1, 2, 3, like this, and then put the carbon like that, and then put the bromine up here. That is also an isomer. And then you kind of got crazy at it in one case, and you really realized that that would also be an isomer. So these are all isomers. They are all the same formula, C4H9Br. I'm just not drawing the hydrogens, but they they all have the same formula, but they all have different structures. Now I'm going to change colors for a second here, and I'm going to go to green. And what I got was some of this 1, 2, 3, 4, and then you went and you put the bromine on the other end, which is the same as that. And I actually showed you that on the video. So the other thing I had people do was, you see this one here, that I then got some people, and I won't name names, they then did this, 1, 2, 3, 4, and they put like this. So these two things are the same, they're just flipped from each other. And think of them three-dimensionally, they're just flipped. If you were to take it and literally flip it like this, you would have the same thing. So be cautious with that. It's really tough to learn this without a molecular model kit. I myself keep one at the house, just at the ready, in case of a pandemic or other issue. Now, that is the story with this. Um, I gave you a little bit of isomer practice and that to work with again, just to do, just to check it out, take a look at it again. All right, now, lastly, tomorrow, Tuesday, Taco Tuesday, we are going to have a quiz. It is not on resonance. It is not on isomerism. It's on Vesper shapes, hybridization, and polarity. Go back to the examples I gave you. I'm not going to reach into the file of whack-a-lacky things. Rather, I'm going to reach in the file of things that are similar to what you've already seen so that I can tell that you know what you're doing. That will be its purpose. It will be a Canvas quiz, and that will be Tuesday's assignment. I put a little itinerary in for you for the week. We are getting near the end of it, kids, and this is pretty much it on Friday of this week. And that, having said that, I'm rather impressed with how well almost all of you are doing. And that, and in some cases, you have far and outside, you have excelled to such a level, I'm just speechless. Do I seem speechless? No, sorry. I will be speechless now. Take care. Have a great rest of your Monday. Goodbye.